G'day. Welcome to Diecast Salvage in Gravesend, Australia. Today we are not painting these vehicles or stripping them, so we're not going to see a naked vehicle. We're going to attempt to show you a process called photogrammetry. And the idea of the photogrammetry is to make parts for these vehicles. Now, yes, I could simply just when I do it off camera, it works. Do it on camera, it don't work. I could simply just glue that in place and put it on my shelf after it's been painted, and that would be fine. This tailgate here is, with this reproduction tailgate, well, it needs lots of work. It needs this filed here to make it smooth. It needs the same thing on our hinge, if the camera will focus. There's a fair amount of flashing on the hinges there, and it risks breaking to become exactly the same as what you've got here. So the quality control, like these might be, sort of £5 or £6, or sort of 12 to 15 Australian dollars, which is a fair whack. It's half the price of what the car can cost, plus postage, of course. Or go down the route of buying a vehicle that has the missing part complete, and as I've done in the past, use a silicon rubber, make a silicon rubber mold, and then use a 2-part resin to make a new part, similar to what Paul Restorer does. That is at the moment one of the best ways to do it. Another way is, if you're good at measuring and drawing, you could use programs like FreeCAD or Fusion 360, Tinkercad, if you're good at designing and you have measurements. But what I'm showing today is another way that you could do how you possibly can make your parts using photogrammetry and 3D printer. Now, this segment may go into 3 parts. We may not do it all today. We may go through the 2 processes and another 2 processes a little bit further down the road. Anyway, enough ranting and rabbiting on. We are going to use this tailgate because this is good. It's in one piece. There is no flashing because it's an original piece. We are going to use this for our photogrammetry work. So let's get on with the show. So this is my new toy. It's called an OpenScan Pi. If you have a look in the middle of the screen, right there, that is the tailgate out of the Vauxhall Victor ambulance that you saw just a moment ago. That was missing its tailgate. That's the tailgate from it. The OpenScan Pi that you're seeing in front of you has a Raspberry Pi little mini computer in here, and it uses a Sony Arducam IMX 519 camera, and it has a diffuser around the outside of it. What this will do is, when it takes its camera, it will turn the object on the what they call a rotor. It'll turn it round. Right. It'll do it in smaller increments than what you just saw, and this part here moves as well. Each time when it stops, it'll take a photograph. They'll do a turn, and that will then move into a different position. And it's all set up through the Raspberry Pi, the computer that's inside that blue 3D printed box there. The other thing that it'll do is it will open up the diffuser, right, so it has an even light process for it. So I'm going to set us up so that you can see what I'm doing on my screen, and you can see what this thing does at the same time. So, see you in a moment.
Alright, down the bottom right hand part of your screen you'll see the OpenScan Pi. I'll just put it there for you. From here, to set it up, it is a browser based, and it is connected up wirelessly, or you can have it via Ethernet cable connected to your computer or your smartphone device, anything that's on the network, to connect it. We're just waiting for it to. It might help if I started the item. You'll see this light here flash a few times, and then it's ready to go out, and hence why we're getting the connection timed out. So we've got to wait for the Raspberry to start up. So my apologies. I thought I was ready, but like a number of times, I'm not ready. So you just saw that light flash. Just give it a moment, and I'll click on try again. And here is our item on our screen. What you're seeing here in the middle of the screen is what the camera is seeing. So it's saying that the item is ready. We're going to change our project name to I'll call it Dinky Tailgate. Just for the purposes. What this rotor does is what I showed you before, but you can see it on screen on the bottom corner there. And this other one will put us in the right position. You generally want this part here to be level when you start up. We'll turn up our ring light. Just wait for the camera to receive it. This blob that you're seeing down the bottom here is a bit of hot glue. That's to hold the tailgate up and down. And we should be able to, later on, in the Mesh Mixer program, out. Fingers crossed we get that far. So the ring light is the amount of light that comes into the middle of the screen. As you can see, it's very bright there. I generally found in my tests so far that if I have it up on the second step, that's where it works best. I'll turn off my other noise maker that you've been hearing in the background. The shutter speed, this will just, you'll see some changes in the photo there. Well, sharpness. I think I had it at 115 last time I did this. So I'll bring it back up to 115. Cleared up the photo a little bit, or the image I should say. The number of photos, according to Photogrammetry, the gurus out there, depending on the subject, somewhere between 150 and 300 photos is good to make 3D objects. I've selected 200, and I've discovered by cropping the image, I'll take them back to how it normally is. This will change. That's how I used to do my tests, used to be, and I had values. But then I did some experimenting after reading, right, researching. It's taken 2.5, almost 3 weeks to get to this stage, where I've had successful repeats on getting to a satisfactory stage where I think I can do a 3D print of this object, of this tailgate. I haven't done it yet at time of making this video. I have not done it yet. This, I think, will be part 1 of a series, because we will be using different programs. This is the OpenScan program, which is web-based, and it is inside the Raspberry Pi, inside this machine here. So that's what we're looking at. We're looking at inside on this machine. Anyway, so we've got this set up. We have this set up. It says up there, we're ready. So this is what we do next. We press that button. As you'll see down the screen down here, that turned around, and this arm here is moving. At each stage, this part up here gives us our photo count. So I'm going to let you watch for it take 20 photos. I will let it run through the process. I will pause you and I'll bring you back when we are ready. Alright, I shall pause you now. So now it has taken our 200 photos. It says scan done or run another pass to finish the project. We can finish the project. And there's the end result of the piece there. From here, we go over to our file/cloud. Here are our 200 photos. Total size is 118 megabytes. It took 11 minutes and 28 seconds to do that. It is now I've now selected the photo set. That's why we now have this photo here. Now I do have a choice to upload it to the OpenScan server, which is cloud-based. It will do the cleaning up of goods, and I will get an email within a few hours with a 3D object. Or I can be silly enough or be adventurous enough and download it onto my computer. Giving it a name. We'll go up one. And we'll save it to there. And it downloads onto your computer just like anything that you download from the internet. But in this case, it is going from the Raspberry Pi, which is the device that made the photos, onto your computer that way. So we can open up that folder. We can extract the files here. Change the view, large icon so we can see what's happening. I'll take this out of here at the moment and bring it up with my other test, which you can fall over here. So I've been doing plenty of tests. In any case, we go back to Dinky Tailgate. There it is there. I'll just move that screen across. We can close that browser down. But what I'm going to do now is compare, just do a quick compare with the previous version that I did of this. Now you'll notice I will be going through these photos to see which ones are good or which ones are going to be shocking. So this is how the scanner took the photos. See, that needs to be out, that's useless. That one is useless. Where I'm doing this demonstration is not normally where I keep that's my backup program, as that's usually in a different room where the lighting is different. So the idea is this is just to give you the demonstration and that you were able to see the OpenScan Pi working in action down here. So I'm going to pause you again. I'm going to go through these photos like I just have. This is going to be part 2. I'll get my fingers in the right place. And the camera. This way, Michael. That way. Part 2. Not that way. That way. Peace. Part 2 of photogrammetry to make a 3D part for a die-cast vehicle. Now you saw before that we got out, if I find the photos, where's my dinky tailgate? There we go. We got up to this stage with the photos, and I was going through to check them up. So we've done all that, and I've already gone a little bit further. I'll now catch you up. So the next program that I am going to use is called 3D Zephyr. Now this part can be a little bit long, so be prepared, but if you're interested, by all means ask questions down below in the comment section. That's what it's there for. I'll see what I can help you. I'll be doing this photogrammetry bits and pieces for about 3 weeks. So I'm a novice at this. I'm flying it by the wings of my ears. But there are enough YouTube videos out there. I'll probably link some in the description as to the videos that I looked at to look at how I got this far. Before I was using Mushroom to do my experimentation with, but I dare say that my computer is not powerful enough to run the Mushroom 2023 version, because well, to be honest, it crapped out on a few issues regarding my photos, but then again, I was using a different set of photos to what we are using today. Anyway, enough wallowing about that. I very much like this program. There is a free version of this program that you can download. I will leave a link down below for it. The drawback is you can only put in 50, that's 50 photos at any one time. So that's the limitation. You get full function of everything, but it's limited to 50 photos, where I'm using 200. Right, so you want 150 plus photos if you're going to do photogrammetry, and this works fine. This is very easy to use. It's just a point and click part of it, and I will pause through the program because it does take a fair while, everything for it. So the first part is we can go up to workflow. We're looking for a new project, and this is what we can do in this project. I will let you read through this section here. The item I'm going to choose for demonstration purposes is model, because that's what I want to create. After I do the demonstration here for you, I will try this texture and this all photo partners. I have no idea what this is, so I'm still learning all this, but I've conquered this part. So now that we click on model, we come down to the bottom and click on next, and we now need to add in our photos, as it says to be professed. You click on plus, you go to where you have your photos located. In my case, I would call it Dicky Tailgate. I'm pressing Control A on my keyboard to select all the photos. Click on Open. It is now going to bring all those photos into the work area, which is the selected, 198 images, because I deleted 2 that were not suitable. From here, we click on Next, and it has now all our cameras. This part here where it says Unknown, that's usually the camera make and the camera model in there, which is derived from what's called metadata, which is usually in your photos. When you take a photo with your camera, with your smartphone, if you look at it in the photo section and you look at the about, you'll see what's called metadata. The date it was taken, how many times you've accessed the photo, where the photo was taken. A lot of times it'll tell you what camera your smartphone uses. That's usually all in the metadata. We don't need to worry about that here. All we need to do is click on Next. It's now asking for camera orientation. This we can just leave for the moment, as we're all new to this. We'll just leave it at the default settings. Click on Next. Now it has what's called a dense point cloud creation. Again, the easiest thing to do is to leave the default setting. Click on Next. We are now changed to the surface reconstruction and desired presets. Again, generally, default settings are good enough. So we'll click on Next. So it says now start reconstruction. So this is how we're going to build our first stage of our 3D model. So this is what we've just gone through. It's going to use 198 cameras. Then reconstruction, we'll just use the default settings. And now we click on Run. This here is a log of what the program is doing. You don't need to have it on. You can just leave it like that. Walk away for a little while because this is going to take about 6 minutes. My preference is to leave the log file on so that you can have a look to see what's happening. So there's a lot of things happening in the background. So Samantha is very busy. So I shall leave her alone. So that means I'm going to pause this video for the moment. You'll be back in a split second and I shall see you shortly. Now, did it cut off? That I don't know. No, it didn't. It was supposed to. Okay, we're about 2/3 of the way through. On here, we've still got another 12 minutes of processing to do. Just wanted to catch you up a little bit while I sit here and twiddle my thumbs. Well, I'm not twiddling my thumbs, I'm doing other things in the background, but I'm trying not to bore you. So again, we'll bring you back when we're a little bit closer. Alright, we have progressed a little bit further. As you can see, it says finalised. A few more minutes for it to finish processing. So Samantha's. So when it has finished its processing, I shall bring you back again. So it is now doing its final summary and going through. Even though it says 10 minutes and 56 seconds, it is flying through at the moment. So we should have a result fairly shortly. As you can see, it is flipping through this section fairly quickly. It says about 8 minutes, which is about right. So again, I shall put you on pause and bring you back when we're a little bit closer. Well, Stasia is running her feet off like this. Let's look at the process that Stasia is doing. It says up there roughly about 1 minute 30 seconds. I know it takes just a little bit longer to go through. So still doing the same process. I'll pause this for a moment until we get the results, so you don't have to be sitting here and watching the jumble go down there. Stasia has gone on to her next stage in the processing of down here. Even though it says 1 second there, she takes a little bit longer than 1 second. So Stasia doesn't quite always tell the truth. But again, I shall pause the video so that it frees up a little bit of memory to help Stasia along. See you in a moment. The reason why I keep this log open is that should there be an error message further down the track, the program always says refer to the log or the log file, because what it's doing is giving a timestamp and what it's doing at that time. So again, I'm just trying to keep things a little bit interested and telling you what I know. We're doing a lot of the cluster together, so to bring the image. That is session summary. So we're just about ready. There we go. So 198 photos out of 198 have been orientated, which means it has been put into the right perspective. That is excellent, considering that this time last week or a week ago that I was maybe getting 4 photos out of 150 being orientated. So doing research and reading and a lot of Googling, we have been able to get things done. So now that we have everything green, we can click on the finish button, and there is our 3D object. So I'm just going to pause you for a moment so that the computer can do the processing and we can have a closer look at this model. here is our now 3D model. That we took 200 photos of. We need to do a bit of cleanup because we don't need to print that part of it. Excuse me. Because at the time I was using a bit of hot glue to hold the tailgate into position. So that is the end of part 2. So we'll see you when we get to the processing of cleaning this up and getting rid of this base. So I will shut down the program if you don't need it. And we shall close you down as well, and we'll see you shortly.